Next topic is thermal equilibrium. Equilibrium means after the final temperature are same of the two bodies or system and surroundings. Okay. When a hot cup of coffee is kept in the room, heat flows from coffee to the surroundings air. Because of hot cup of the coffee, it has a more temperature, higher temperature than the surroundings. After some time, the coffee reaches the same temperature as the surrounding air, and there will be no heat flow from coffee to air or air to coffee. Okay, so no heat flow from coffee to air or air to coffee. This means the both the things, that is hot coffee and surroundings, are attained that same temperature. Okay, it implies that the coffee and surroundings are under thermal equilibrium with each other. Okay, this is the meaning of thermal equilibrium. Okay, so both the objects having at the same temperature, which means system and surroundings. Okay, so the definition of thermal equilibrium: two systems are said to be in thermal equilibrium with each other if they are at the same temperature. Clear? After the thermal exchanges, both the things having the same temperature, which will not exchange with time. Okay. Next, we will see that mechanical equilibrium. Mechanical means we have to do the work. Okay. That may be equal in the temperature. Let's see. See the diagram. So this is called the cylinder. This is piston, is the movable piston. Here we have placed the gases inside the cylinder. Okay. Consider a gas container with the piston shown in figure. When some mass is placed on the piston, see the masses are placed on the system. What will happen? So mass means it has more weight. So the due to the gravitation force which acting downwards, so it go to downwards. The piston move downwards. Okay. It will move the downward due to the downward gravitation force, and after certain humps means make up and down like that. Okay, and jumps, the piston will come to rest at any position. Okay, see, initially it has no mass we have placed on the piston. Suppose we place the masses on the piston, it will be moved downwards. After some time, the piston reaches the stable position, which means the weight of the masses is put into acting downwards the piston. At the same time, the gas is placed inside the cylinder. It has producing a upward thrust, correct? That both are balanced. The downward gravitation force is balanced by the gas upthrust. Okay, then it's said to be in a mechanical equilibrium. See here. Yeah, when the downward gravitation force given by the piston is balanced by the upward force or upthrust exerted by the gas, so the system is said to be in a mechanical equilibrium. Okay, so definition: a system is said to be in mechanical equilibrium if no unbalanced force acts on the thermodynamic system or on the surroundings by the thermodynamic system. Clear? Next is chemical equilibrium. Chemical means that is what you have to change in a state like that, or chemical reactions. If there is no net chemical reaction between the two thermodynamic systems in contact with each other, then it is said to be in a chemical equilibrium. Okay, it's very simple, understand the concept. No chemical reaction between the two thermodynamic systems. Okay, so what is the things we have to place? That is, after reaction, it will be change in state, but the net chemical reaction is the same. Okay, there is no, clear? There is no net chemical reaction between the system. Is called chemical equilibrium. Next is the thermodynamic equilibrium. If two systems are said to be in thermodynamic equilibrium, then the system are at thermal, mechanical, and chemical equilibrium with each other. Okay. See, in the state of thermodynamic equilibrium, the macro means 10 power 6 in sizes, is variables such as pressure, volume, and temperature that will have that fixed values and do not change with the time. Okay. So the state of the thermodynamic equilibrium means what? The pressure, volume, temperature, okay, all are fixed. There's no change of its value. Okay, this meaning of thermodynamic equilibrium. Okay. Next, you see that what are the states of the variables in a thermodynamic system. In mechanics, we can say the term velocity, momentum, and acceleration, force, etc., that are used in explain the state of the any moving object. Okay, which you would have realized in volume 1. This is first volume. Okay, here in thermodynamic system, the state of a thermodynamic system is represented by the set of variables are called the thermodynamic variables. So variables what? It is not remain same. It will be changes. Okay, with respect to the temperature or time or position or place, whatever, it will be variables, changes. For example, pressure is variable, temperature is also variable, volume also variable, and internal energy also variable, and etc. Okay, the values of these variables completely describe the equilibrium state of a thermodynamic system. Okay, then heat and work are not state variables. It always changes. Okay, rather they are process variables. Clear? Under the action, it will be changes. Same work also. Okay, so this is not variables. Clear? There are two types of the thermodynamic variables. It's called extensive and intensive. Okay, extensive and intensive. For example, volume, total mass, entropy, internal energy, heat capacity, or etc. are called that extensive variable, which are depends on the size or mass of the system. Okay, size means the shape. Okay, then mass. So according to size, mass also will be variable. Clear? If the volume is in a two-dimensional L into B, case of the three-dimensional L into B into H. Okay, so mass is variable means size also variable. Okay, intensive variables means they do not depend on the size or mass of variables. Okay, they not depends. For example, temperature is a high or lower value only. Pressure is also same, high pressure, low pressure. Then specific heat capacity also same thing. Even density also same thing. Density also thing. Okay, here they depends upon only the quantity, like a high or low. But here they depends upon the mass and size of the object. It's a quantity. So extensive variables, simply you can say this depends upon the quantity. Intensive variables, it does not depend upon the quantity. Okay. Next is equation of state. Is a 2 mark question. The equation of which connects the state variables in a specific manner is called the equation of state. Okay. So what are things we have to take in a reaction or equilibrium? It is same. Okay. Yeah, the thermodynamic equilibrium is completely specified by these state variables by the equation of state. Okay, if the system is not in thermodynamic equilibrium, then these equations cannot be specify the state of the system. Okay, for example, an ideal gas, ideal gas, that is PV equal to NKT, obeys the equation. P is the pressure, V is the volume, is equal to number of moles, K is called gas constant, T is temperature. Okay, here the P, V, T and N are connected with this equation. We cannot change one variable alone. For example, if we push the piston of a gas container, the volume will be gas decreases. Pushing downwards, the volume will be decreases, but pressure will be increases. Or if heat is supplied to the gas, its temperature will be increases, pressure and volume of gas may be increases. Clear? So we can change which depends upon all the three values. It's not by the individual values. Okay, there's another example of the equation of state is called the van der Waals equation. So van der Waals equation is obeys that equation that at the thermodynamic equilibrium, the air molecules in the room truly obey van der Waals equation of state, but the room temperature with the low density we cannot approximate into ideal gases. Okay, so room temperature means it will be varies. Clear? Yeah, so only the real gases. The real gas means which makes that intact to the other molecules. For ideal gas means is it do not interact with the other molecules. It keep it isolated, separate. Okay, so the real gases always obeys this equation. Okay, clear?